Good day, class. I am glad that you all can make it today for this video lecture. Identifying points, lines, and planes, so by the end of this you should be able to name some common shapes that we use in geometry. The first three, point, line, and plane, are actually technically undefined. Undefined means there's no formal definition, just stuff that we have accepted to be true. It's represented by a dot, a line, or a quadrilateral. A point, no dimension. It actually doesn't take up any space whatsoever. It's represented by a dot. A line, one dimension. It goes one way or the other, continues forever. Note, through any 2 points there's exactly one line. So if I have 2 points, I can draw a line through them, and there's only one line that can do that. Plane has 2 dimensions, is represented by, again, a quadrilateral. Generally we'll draw a parallelogram. It also continues forever in every direction. It's basically like a wall without end, or a floor that never stops. But we just draw a quadrilateral. Please note, through any 3 points, there's only one plane. So if I would look at this, there's a whole lot to look at. But let's just first of all look at these red dots. These are what we're going to call our points. If I was going to label this, the easiest way to label would just be to write the capital letter. Please note, dots will always be labeled as a capital letter. If I said point C, it might take you a little while to locate it, but it's this dot right here. Before I said through any 2 points there's exactly one line. That's how we label a line. If I said line FG, you should be able to point it out. It's going to be this shape right here that goes through the points F and D. If I said line BF, you should be able to find point B and point F, and this is the line. Please note, if I'm writing just point, I can just write the capital letter. I read that as point A, point B, or point C. I can rewrite out the word just to clarify, point A, so I don't get confused if I'm actually using the letter A. Line BD, line BF, line FG, I can either write out the word again, or I can take the shortcut, use the 2 points that I'm going to name it with, and draw a line over it. For instance, these are all the unique lines on the plane, or sorry, on this screen that you are seeing. Please note that each box represents a different line. So for instance, all 6 of these represent this one shape. You can use any of them to name it, and it's appropriate. Please note, I did not use either of those 2 because those are wrong. You only use 2 points to represent a line. So please never use 3. There is another way to call a line. If you notice right underneath this shape right here, we have line L. That's because I labeled this one with an L. So that would be talking about this shape right here. Okay. This box right here, CB and BC, also describe what we would call line L. All of them are fine and appropriate names. It's really your choice, but you just got to be clear with which one you're talking. Now we're moving on to planes. Planes are 2-dimensional shapes, like a quadrilateral. We use 3 points, or again, just like the line, we use a single letter. For this one right here, there are these 6 names just using the points H, I, and J. If I add in K, I can easily erase any single one of these points in the name and place it there. So instead of HIJ, it could be HIK, HJK, so on and so forth. If there's a single letter not associated with a point, like this R right here, it could be plain R. Please note, I could not use point L here because it's not on the plane. If I called it plane HIL, wrong. Alright, there's other shapes other than line, plane, and point. Line segment and array. Line segment is just a shortened line. We have to be a little bit more specific when we name this one. We use only the endpoints. If there's a point between, I will not use that in its name. I will use only point of the endpoints. There is also not a cursive option here. I cannot label a line segment like L. Nope, just doesn't work. And then array, we name it by endpoint. Sorry, I should do it this way. Endpoint toward another point. Line segments would be any of these shapes that end. The one with points E and D up here, that would be a line segment. Points A and C, line segment. Nope, those are the only 2 by themselves line segments. However, if I was only talking about from F to B, I could be talking about just this part of this ray. If I was talking about just this part, I could say line segment FB. Now you can write out the words line segment or segment AC. However, I find it a lot easier to just, again, use the points A, C, put a segment above it. If it's a line segment, it doesn't matter if I would call it AC or CA. Same thing with GI here. Again, segment GI is only talking about from point G to I. That's the shape. It's not talking about from I and beyond. So those are line segments. There's a lot in this. If I named them all, it'd be staggering. But same thing here. I cannot call line segment AC, ABC. Just not going to work. 2 points for anything that's like one dimension. 3 for anything that's really two dimension. For array, for instance, starting from point G through I here, this would be called array GI. We always start with a point that's an endpoint. By the way, an endpoint's a point on the end. So point G here is the point on the end of my array. So that's the end point of my array. GI. This is a perfectly fine way to name array. However, array IG, that's saying I started at I, went through G. This does not work. If I'm talking about array LJ, that is array, it got covered up a little bit from the X. Well, that means I start at L, I go through J. It's written correctly. You might ask this, what if I wrote array JL this way? No, you see what I did there? I even accidentally went to JL. We read left to right. So this, even though it started with the endpoint being L and another point being J, it's just kind of weird to read, and you're going to probably mess it up. So we only write it rays going left to right, even if it's going right to left, which LJ is. Ray LJ is. Ray FB has two other names. What are they? Yep, these are them. Remember, you can name array with either a line array above it, or you can write out the word ray in front. Either one works. The very first example you will see: name all unique rays, lines, segments, planes, and points. So I'm only asking for one name each. What are they? All right, something like this, you're going to want to start at one point, or something along those lines. Let's start with just points. What points do I have? Those are all of its unique points. For this one, you're going to have to be a little bit careful, because even stuff that doesn't look like necessarily a segment will be a segment. Those two are the ones that you should see right away, because those are actually the segments in the diagram. However, there's at least a few more. No joke. That's all of them. Yes, even the shapes that don't necessarily look like segments are segments. So, all the unique points, all the unique segments, we've got the big ones down. Please note, you might have a different name, but those are the only two unique lines. If I'd go from A to the right, that's array. So I could have ray AB as an option. Ray AC is the same ray, so I'm not going to list it. However, what if I instead start at point B? The ray can go to the right or to the left. So for instance, if I'm starting at point B here, it could go from point B all the way forever this way. That's array. That means we're ignoring this entire left side. BC, ray BC is a possible one. Also on the other note, ray BA. Please note that ray AB and ray BC or BA are different rays. So even though I said before that you can't switch them, in this case, because it's part of a line, that is actually a ray in there. The last ray, CA, you could have also called it CB, but it's not unique if I would go further. Those are all the unique rays on this diagram. Yes, there's no ray drawn specifically, however, they are part of the line. And the last thing, one, I'm going to go the easy way, just label it by the capital letter. Plane S. So I labeled the horizontal looking plane, this one right here, the blue one. That's the plane that I called plane S. The other one, let's do a little bit tougher. Let's choose 3 points on plane R. One thing, they can't be collinear. Collinear, sharing the same line. Coplanar, sharing the same plane. So, if I choose 3 points, I cannot choose points A, B, and C because they're all on the same line. I could choose points B, C, and D though. Or B, C, and E because they're not on the same line. They're not collinear. And B, C, and E are all coplanar. I cannot choose B, C, and J. While they are non-collinear, they're not coplanar. So for plane R, the yellow plane, yellowish plane, we're going to call it plane BCE. Those are all the unique rays, lines, segments, planes, and points. Now that we've talked about the different shapes, what about something called an intersection? An intersection is any time we have two shapes meeting or crossing. You can think of like a road here. When we have two roads meet, that's an intersection. Two shapes crossing. So, intersection of two lines, always a point. Intersection of two planes, always a line. One dimension less. Example 2. Sketch all interactions of a line and a plane. Yes, I realize I labeled it wrong. Not going back and changing it. It's example 2. There are 3 different ways. Take your best guess. If those are the 3 you said, good. The first case, there is actually not an intersection. They never meet. They're parallel. Second option, it crosses. Third option, it's actually inside the plane. Those are the 3 different ways for a line and a plane to intersect. I could ask you the intersections of different shapes. So for instance, what's the intersection of plane ABD and plane AEF? Plane ABD is this red shape. Plane AEF is this left side of the cube. Where they both overlap will actually be segment AB. So my answer for number 1 is segment AB. Alright, the next 4, well, line AD and line HD. So line AD goes left to right here, line HD goes here. They both overlap at D. Please note that when I say this, I'm actually thinking of this as going on forever in this direction. Okay, and the same thing here. And on the other side. So when even though this is a segment, if I'm talking about line AD and line HD, it's actually talking about the continuation, the actual line itself. So where they both overlap, point E. Now I could just talk about segments. Segment EF and segment GF. Well, just by looking at their name, they both have F. They're probably going to intersect at point F for sure. I look at point F. GF goes to the right here. EF comes sort of out of the screen. So if I look at where they intersect, it's point F. They both have F. How about plane EFH and plane ABC? Well, plane ABC is the top. Plane EFH is the bottom. It's the top and bottom of a cube. If I would extend this forever, never intersect. Segment AD and segment HG. These here, if I could draw a line and continue it on forever this way, and same thing here, but they will never cross. This can be done by using a string. If I would have a string going this way and then I had another string underneath going out toward you, the only spot they could have crossed would have been in this area. But they never did. It's hard to draw 3 dimensions. Even though these might cross eventually, they don't actually ever cross. Their only chance to cross would have been in this area, cube area. Alright, at this point you should now be able to identify the points, lines, segments, rays. You should be able to name them. You should be able to identify them by sight. You should even be able to sketch a few. Identify points of intersection. If I ask you what's the intersection of 2 lines, you should always answer with a point.